This research line is within the scope of project PERSEVERE, a project funded by the European Commission. It's a Marie Curie postdoctoral fellowship whose target is the use of physics-informed neural networks for severe weather event prediction. What we do is that we apply methods based on artificial intelligence, and we try to reconstruct how the weather field looks like in high density. Because originally the weather is based on satellite images, from which we only know, for example, cloud coverage, but satellite images do not provide very precise information on the velocity field, for example, or the pressure. We measure that by weather stations on ground. Weather stations on ground are very sparse, we don't have that many available. So how does the weather look like in other places? We want to reconstruct that using artificial intelligence. We also try to enhance that reconstruction of the weather field by providing weather nowcasting and weather forecasting. Nowcasting is when you take the image plus minus whatever amount of time within the time span of 1 hour after the time of the intake, and forecasting will be, for example, the prediction in 2 hours, 3 hours, 1 day plus. What we need to do is to add more data to our neural networks and be able to get more precise information from the weather stations and the satellites, both at the same time, and that poses a challenge for the short term. The natural tendency for this research line will be going from data enhancement to nowcasting and then to forecasting. Once we have reached a very good weather forecasting, now we will, let's say, guide our research to other more interesting topics, for example, climate change, or how does aviation affect the greenhouse effect. We will be more tackling climate effects than weather forecasting.